So now we're looking at probability packet section 5, and we have this set of cards that have letters on them that spell out mathematics. And so as we're solving this set, we got to keep in mind the letters that we have, in some cases more than one of each letter, and the chance or the probability of choosing one of these cards if we were to shuffle them and just take one out of the deck. So the first one, the probability of choosing an E out of the deck, it looks like there's only one E. And the question is, how many cards are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1 out of 11. We're just going to leave these in fractions for now and not worry about the percents of these. So keep it simple. So if the probability of an E is 1 out of 11, then the probability of not choosing an E would be all the rest. And since there's 11 cards, that would be 10 of the 11. And then the probability of an S. The letter S only occurs once in this deck again. So again, we would have a 1 out of 11 chance of choosing the letter S. Okay, now it's a little bit more challenging. We have to think a little bit about what some of these terms mean. A vowel. So A, E, A, and I. So we have 1, 2, 3, 4 vowels out of 11 cards in the deck. Be our probability. All right, now things get a little bit more interesting. So the second half of the alphabet. So the middle of the alphabet is the letter M. So after M comes N. And so N is the first letter of the second half of the alphabet. So looks like first half, second half, first half, first half, first half, first half, second half, first half, second half. So we have a T, and an S that are in the second half. So that's 3 out of 11 that are in the second half of the alphabet. All right, now it gets even more challenging because now we're going to have something called an OR statement. And with an OR statement, this or this can be true. So we're going to look at what we have. In the case of number 4, we had all the vowels, which is 4. So there's 4 vowels. And then there's 3 that are the second half of the alphabet. So when it says or, it's this or this can be true. So in the case of second half, there was 3 of 11. And vowels, there were 4 of 11. So together, 4 and 3 is 7 out of the 11 fit this description. They are either a part of the second half of the alphabet or they are vowels. Now, none of the vowels that we had were a part of the second half of the alphabet, so there's no overlap in these two. So that works out well. So second half, so we had the T and the other T and the S. So there's 3 there, and then vowels 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7 of the cards fit this description. Okay. Now we have this other statement that says and. Now and is more exclusive because it means that both of these have to be true. It has to be a second half of the alphabet and a vowel. So if you look at the cards up here, is there a card that is a part of the second half of the alphabet and it's a vowel? We already said that none of the vowels, A, E, A, and I, none of them were a part of the second half of the alphabet. So in this case, none of these would be true. So we have 0 out of 11 that would be the case for this because there are no second half vowels. It has to be second half and a vowel, and none of those in that deck are true for that. So now We look at another and one, and the and ones again are more exclusive. There's usually less that are true because it has to be both. It has to be before the letter I and a vowel. So that's pretty simple. Before I and a vowel. So we're really only looking at vowels. A and E and A. That's before I and a vowel. That's before I and a vowel. The A is before I and a vowel. And we're not going to include this I because it says before I and a vowel. So this one doesn't count because it's not before itself. So we have 1, 2, 3 out of 11 that are before I and a vowel. And you can see that the and statements give you less than the or statements because the last one is or. So we're going to say before I or a vowel. So anything that's before I will count or a vowel. So I'm going to go back to here. So that's before I or a vowel. H is before I or a vowel. So now I have 2. And E is before I or a vowel. So now I have 3. So that one, I'm going to mark them. And that one. And that one. And A is before I or a vowel, and T is not, and I is before I, no, but it's a vowel, so I get to count it. And C is before I, or a vowel, so this is the before I. So a vowel, a vowel, a vowel, a vowel, before I, and before I. So you can see that I get more. 1, 2, 3, 4, 5, 6 out of 11. 6 of the 11 are before I or a vowel. So you get more with or. You usually have less with the and. More with or. The or gave us more possibilities because it's this or that. In this case, it has to be both. And means both have to be true. Or means either can be true. So that makes things a little bit more challenging when you start looking at things with or and statements in the probability situation.